You've seen that supervised machine learning algorithms can classify your data. Unsupervised machine learning algorithms can cluster your data. Now let's look at an entirely different set of algorithms based on conditional probability. Say you're looking to see how one thing impacts the probability of another thing happening. The most popular algorithm for this type of analysis is called the Bayesian algorithm based on the Bayes theory of statistics. Naive Bayes is one of the most popular Bayesian machine learning algorithms. It's called naive because it assumes that all of the predictors are independent from one another. Naive Bayes is mostly used for binary or multi-class classification. Let's go back to our animal shelter in Chicago. Imagine that we wanted to classify all the dogs in the shelter based on their different breeds. Remember that there are hundreds of different dog breeds. On top of that, most dogs would be a mixture of several breeds. Let's look at this problem using a naive Bayes machine learning algorithm. To start, let's create 3 classes of dog breeds. We'll use terrier, hounds, and sport dogs. Now, for each of these classes, we'll have 3 predictors. Let's use hair length, height, and weight. Remember that some of the predictors will be closely autocorrelated. A tall dog is more likely to be heavier. But naive Bayes considers each one of these predictors independently. Remember, that's why it's called naive. Once you have your classes and predictors set up, then the naive Bayes machine learning algorithm starts with something called class predictor probability. This is when it looks at each of the independent predictors and tries to create a probability that the dog belongs in each class. Let's see what happens when you're trying to identify an unknown dog. The first predictor you look at is hair length. The machine learning algorithm can check the probability of a dog with this hair length, belonging to any of the 3 classes. It finds that a dog with this hair length has a 40% chance of being a terrier, a 10% chance of being a hound, and a 50% chance that it's a sport dog. The next thing you check is the unknown dog's height. Again, naive Bayes doesn't correlate the dog's hair length with the dog's height. It looks at this predictor independently and tries to calculate the probability that this unknown dog will belong to each class. So, again, it looks at the training data and finds that there's a 20% chance that it's a terrier, a 10% chance that it's a hound, and a 70% chance that it's a sport dog. The final thing you want to check is the unknown dog's weight. This might seem like a strange predictor because it's closely related to height. But remember, the naive Bayes is evaluating the probability of each predictor independently. It looks at the training data and finds there's a 10% chance it's a terrier, a 5% chance that it's a hound, and an 85% chance that it's a sport dog. You now have this table with the unknown dog's class predictor probability. If you look at it, you can see that the dog is probably a sport dog. But remember, most machine learning problems are dealing with terabytes or even petabytes of dog data and is trying to classify millions of unknown dogs. To classify your dog, you might want to use something called the weighted multiplication function. Since this is a weighted function, the first thing you want to do is create a weight. It's here you'll decide which one of your predictors is the most predictive. You can pick this weight by looking at the training data. You can also tweak it if it improves your accuracy. Here we'll use a weight of 3 for hair and 2 for weight and height. For the weighted multiplication function, take the predictor and multiply it by your weight. When you add up the predictors for hair length, height, and weight, you can see that the second unknown dog is most likely a sport dog. It's less likely that it's a terrier and very unlikely that it's a hound.